This is going to be a very special session. You are well aware of the title, of course. Maybe you've seen the first session, the first introduction of these guys' work last year. Bluetooth is kind of a quasi-standard in near-range wireless technology in connecting small devices. And of course, it can be a very complex technology, and it has a wide range of applications, which means it can be very interesting to explore, and it can inspire great curiosity in some species of people. Ladies and gentlemen, it's time to watch your cell phones. Last year, they introduced Bluver. Let's see what else they have been working on. We are very proud to have here Martin Herfurth, Marcel Holtmann, and Adam Laurie. Give a warm welcome.
Thank you. And yeah, thank you for having us back again. Hopefully, we're going to introduce some new stuff which you'll find interesting. We're not just going over old ground, but we'll go over the existing attacks as well, so for those of you that didn't see the last time or aren't aware of what's out there. So the agenda will be, we're going to go quickly over the technology, not too much on that. We're going to try and make this as interactive as possible. So when we get to the actual demonstrations of attacks, we'll try and do, or audits I should say, we'll try and do as much as we can with the audience. So if you want to participate, leave your Bluetooth switched on. You can trust us. But having said that, if you don't, switch it off, because the more devices there are, the longer the scans take, and that's kind of boring, waiting for scans to finish. But we see some interesting stuff normally when we scan the room. So we'll go through the technology, we'll go through the security mechanisms, the known vulnerabilities, and then we'll introduce the new stuff we've been working on for the last year and move quickly on to the demonstrations. So who we are, we have Marcel Holtmann on the end here. He's the co-maintainer, the sole maintainer of the Linux Bluetooth stack, BlueZ. So any of you who are using Linux or developing new interesting phones and things, you're probably using his tools. Martin on the end, the far end from me, is a security researcher from Salzburg. He founded the group tryfinite.org that we're all members of, and we welcome new members, anyone who's working in this field who wants to get in touch with us, maybe join the group. You're always welcome, so go and have a look. The tryfinite.org is our main site. I'm Adam Laurie. I work for the Bunker Secure Hosting. I'm the Chief Security Officer there, and I also publish Apache SSL. I also get involved in a global conference, yeah, it's becoming global, but a sister of a global conference, DEF CON. So I know how hard these guys work putting this on. It's really nice to be somewhere and not actually be responsible for any of it. So we're coming to the end of the conference. I think we should all say a big thank you to the guys who put this on, the Angels and Tim Pritlove and all his gang. So thanks guys, great conference. So this is what we're worried about.
Okay, does this work? Okay, nice.
Yeah, so Marcel's going to give us
basically, first one question. Who of you used Bluetooth before? Hands up. Oh, and the other way around? Who doesn't? That's quite still a lot. So another question, who knows how it works? It's almost the same as last year when I had these questions. So basically what we do, we have a quick introduction. I switch to this microphone. I'm using this microphone now, so it's easier. Basically, Bluetooth is a standard, and it's defined by the Bluetooth SIG, Special Interest Group. It's a trade association founded in '98, and they license and own the IP behind Bluetooth. Basically what I always say, it's a general cable replacement, and we try to replace every cable. So meaningless, except two exceptions. It's the power cable, okay, batteries and other stuff we have for that, and the monitor cable, or the VGA cable. So we can't really do transmit videos over Bluetooth. Actually we can, but we don't have the bandwise. Bluetooth is some kind of limited to 1 or 3 Mbit bandwise. It uses ISM band, 2.4 gigahertz, the same as Wi-Fi, wireless LAN. And the funny thing is they defined it basically from scratch, the complete protocol stack and applications running on top of it. A little bit to the topology. Basically, when they designed Bluetooth, they also introduced the words piconet and scatternet. So every device that is communicating with another device creates a piconet. Basically, the first one of it. The piconet 1 is one piconet, and every piconet has a master with the M in it and a slave, and basically up to unlimited parked devices or inactive devices, etc. The piconet is an interesting thing because the piconet is defined by a hopping sequence. The Bluetooth stick said, okay, we use a 2.4 gigahertz ISM band. Okay, they have a range and they separated the complete band into 79 channels. Okay, let's use these channels responsible. Change them 1,600 times a second. So they hop a lot to these 79 channels. So what you saw in the earlier days when you had Bluetooth and wireless LAN in the same area, basically the wireless LAN went down because Bluetooth is hopping through the complete spectrum and blocking the wireless LAN. To play nice with it, the Bluetooth SIG introduced something that's called adaptive frequency hopping. It's basically meaning they reduce the hopping sequence from 79 channels to 60 channels or something if they found a wireless device, Wi-Fi device or any other device in that band transmitting there. So it tries to play too nice to others, but for that you need a Bluetooth 1.2 device. Otherwise it's not possible. There are some other limitations with a piconet. Okay, you can have one master, really only one, and up to 7 active slaves. So basically nowadays every chip supports 7 slaves. The funny thing is they designed it that you can have up to unlimited parked or inactive devices in a piconet, but in general no chip is capable of handling this much devices because they need storage to store the addresses for these devices, and basically the chips are small, the chips supposed to be small, and there's no space, no memory for it to store it. So the general rule is one master and 7 slaves. That's the general rule for any Bluetooth chip that I've seen so far. The interesting, okay, now we are limited to 7 active devices, one master makes 8 devices. If you want to have more than one piconet, what do? We put 2 piconets together and form a scatternet. And otherwise, word they created with Bluetooth. Basically, you can have a bridging device. In this case, it's slave in both devices, but you can also have its master in one device and slave in another piconet, and then you create a scatternet too. The only thing that you can't do is have a master that is part of 2 different piconets. Because, as I said, the piconet is defined by the hopping sequence, and the hopping sequence is defined by the master's clock, and so it's basically the same piconet if you be the master of one. Okay, as I said, it's going to be a quick introduction, so we left almost a lot of stuff out for what really Bluetooth is and how it works. So if you want more information, go to our website and download the older presentations. There's a lot more information in there, but what we need is a general stack. So this is a Bluetooth 1.1 stack. It's quite easy when you look at it. So we have a Bluetooth radio on the layer down, and we have a baseband AV link manager. This is basically what the hardware of Bluetooth. If you buy a Bluetooth dongle, USB dongle, PCMCA card, or whatever, this is what you get. A radio, baseband, and a link manager. Then you get an interface called HCI, host controller interface, which is USB, PCMCA, or whatever standard you want to have. And the rest is running on your PC side. In case of a mobile phone or a PDA or whatever, everything of this is running inside the phone, but it's still separated. This is the hardware piece, and this is running on the CPU of the phone. This is defined by the Bluetooth stick, and up to these layers is also defined by the Bluetooth stick. Okay, L2CAP means logical link control and adaptation protocol. It's basically there for doing multiplexing, segmentation and reassembly and other stuff to abstract from the real packets that are going over the air. The RFCOM is derived from the IRCOM, from the infrared standard. Is basically a serial port emulation. TCS is a telephonic control system and is basically there for attaching your mobile phone to a landline base station, and let's make it connected to DECT or ISDN or whatever. Obviously the mobile phone provider never really liked that because they want to have you use their mobile phones and give them your money. The SDP is a service discovery protocol. It's basically a protocol designed, okay, here's a device, no device, please tell me what services you support, what applications can I do with you. For example, can I use you to dial up into the internet? Can I use you to make a voice, use your headset, or whatever thing you can think of, or send a business card or something like that. The stuff above this layer is basically adapted from already existing protocol suites, RFCs, or whatever. So the OBEX from the infrared specification, TCP/IP and PPP from the RFCs, AT commands from the ETSI specification, and there are a lot of more protocols that they adapted to make it easy for the vendors in the early days to implement everything. And on top of it, of course, you have the applications that are running. For example, WV dial for dial up the internet, or an OBEX push application to send a business card or something like that. I basically like to divide the stack into these three parts, and we also did the separation for the security in this part. So on the hardware level, we have the Bluetooth security mechanism on the Bluetooth chip. The cipher and the authentication mechanism are all implemented in the hardware for Bluetooth. There's no software implementation. So what you have to, on the Bluetooth host security mechanism, which is basically the Bluetooth stack, you have only two functions. The chip needs a pin. The host has to enter a pin, so it has to display some kind of dialog box where you enter the pin code, and then has to generate a link key. A link key is a unique identifier for accessing the Piconet, generate it, and then notify the host about the link key so it can store it. For further connection, it has to provide the link key to the Bluetooth chip, etc. That's basically what the host security is about. And of course, on the higher layers, the application securities, TLS, SSL, SSH, any authentication scheme, for example, from PPP or OBEX or whatever, what you can ever think of. Another thing is that they really put into, which is really a nice thing, they defined 3 different security modes. So basically, security mode 1 means no active security enforcement. This doesn't mean no security at all. It means only, okay, we play along without security as long as both sides agree. If one side wants security, the other one has to comply and say, okay, then we do security. It's a basic definition, but it's a good one. So not if the one side says, okay, I can't do any encryption or authentication or any security at all, it says, okay, then we can't establish a Piconet, period, that's it. Security mode is of course based on, security mode 2 is of course based on security mode 1 and says, okay, if a service is there running, for example, dialing up the internet, then please authenticate yourself and activate encryption, etc. The security mode 3 is another thing that they said, okay, we need for every low-level Piconet connection, we need security mode 3. So whatever you want to do before you establish the Piconet finally, you have to do with the authentication and also the encryption. What do you think? What is the most secure mode? Again, please? 2 or 3? Okay, 1 is obviously not. What is the most secure mode? 2 or 3? Hands up for 2. Hands up for 3. Hands up who don't know. Okay. The funny thing, the security mode 3 must not be obviously the most secure mode. Because, for example, if you have 2 services running, for example, pushing a business card and another one to dial up the internet, you don't want to have security for the business card exchange because, as I always say, you don't give the key to your host to someone that you barely know, but you maybe give your business card away. In security mode 3, you gave them basically the key to your host. Security mode 3, you can separate between these. So there's a white paper out there from the Bluetooth SIG that says security mode 3 is the most secure mode. That is simply wrong, and it will be corrected in the near future. So basically what you want to have security mode 2 with an additional policy manager to manage your different services. Keep that in mind. Don't ever trust the high numbers. They're not always right. Okay, as I said, we have something that is doing authentication and encryption, etc. So basically, the Bluetooth SIG has one problem. They named everything different. It's really odd. So authentication basically means something like pairing, or maybe you heard of bonding. So pairing is, in general, the creation of a link key. So to create a link key, you need a random number that is provided by the hardware, blah, 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 but you also need a PIN code. And the PIN code must be entered on both sides of the connection, and it must be the same PIN code. So basically, the hardware says, okay, give me the PIN code. It gives you an event, okay, please give me the PIN code Okay, yeah, here's now my pin code, blah, blah, blah. User entered 1, 2, 3, 4, 5, 6, 7, 8, whatever, pressed enter. It sent the pin code down to the hardware, and the hardware then creates the link key for you. That is all what the host needs to do to establish an authentication. So, first connection. First time both devices haven't seen each other. Once the link key is created, the hardware will ask you for the link key, and then you put in the link key that you obviously stored somewhere safe, basically. And then you send this down, and then you have the same authentication. Some newer devices create a new link key on any successful authentication, which is quite a nice thing, because another problem with a link key is it has no expiration date, so it is valid forever. So they tend to generate a new one from time to time, which is basically a good thing. Before we step over to some real nice stuff, some nice things. We had looked up the principles of good security. So basically, we have 5 of them. Confidentiality, data must be kept private. Integrity, you must make sure that the data can't be modified, unauthorized modified. Availability, the data must be available if you need it. So for example, if you take your phone and you want to look up a contact or a phone number, it must be there. Authentication, okay. If you want to do something with the data, the peer must be proven that is the person or the device within, that is authenticated to do this. And non-repudiation. I always do this wrong, right?
Non-repudiation.
Yeah. Thank you. It's basically some kind of logging, so the peer can't deny that a transaction has taken place. So what we found with our first attack, it breaks all of them. So basically, we can read the data, we can modify the data, and we will actually see this later. We can delete the data. We want to bypass the authentication. That's the complete point behind it. And there's no logging at all. Basically, you can't keep track of what happens on small devices. Okay. I'll leave this standing as it is.
Right, it's my turn? Oh yeah, I guess all of you remember Paris Hilton and Tinkerbell, her little dog. And obviously data can be compromised from phones, so that's just a sample to show you how important it would be that your data stays private as it is on your phone, probably.
Hang on, go back to that one a second.
Sorry.
We should point out, of course, that I just like looking at the pictures, actually. Now, we should point out this one, as you probably know, is not a Bluetooth attack. This was done by other means. But a lot of the feedback we get with this kind of stuff is, oh, you can hack my phone, so what? There's nothing in there. In this case, there was some interesting stuff. A lot of people whose phone numbers got compromised had a lot of trouble caused to them because of that. Secret Service actually lost some confidential documents through the same hack. So they obviously got quite worked up about the whole thing. So, you know, there's quite often more in your device to worry about than you might think at first. So that's why we take it seriously.
Right. So what I'm going to do now is I'm going through the older Bluetooth attacks that we've presented partly last year, just for you to remember them, because parts of them are parts of newer attacks that we present today. So the blue snarf, which has been discovered by Marcel and by Adam about the same time, is like connecting to the OBEX push channel and pulling off data, which is not supposed to be pulled off since it's an OBEX push service. I think this picture shows it quite well. You see the Bluetooth protocol stack here, and the green path is the path of the attacker that exploits the backplane, the OBEX part, which is connected to channel 3 and channel 4, which makes it possible for the attacker to get to the contacts of this device. The blue bug attack has been exploiting AT commands by connecting to a cover channel on the phone, and you all know what AT commands might do to a phone. So there's also the possibility to cause extra costs. Hellomoto has been discovered shortly thereafter. It's also taken advantage of the AT commands, plus needs some OBEX in order to get into the device's trust model in order to exploit it. Authentication abuse. I'm not really sure when did we start, or which attack was the last one that we presented last year. Do you know that? Authentication abuse. Yeah, probably we didn't present this one, but this is a growing presentation, so every time we do it, we have something new, and I guess authentication abuse wasn't presented last year, so I will extend a little more on that. So authentication abuse is if you have two devices paired up for a task like sending an OBEX vCard. This can be forced if you set yourself to mode 3, forcing the other device to pair with you. Then having that valid link key, you can do and access everything on this other device, even though you just pretended to just send a vCard over. So this includes connecting to the serial port profile, dial-up networking, OBEX file transfer, pretty much everything. So this is like a failure that manufacturers did by using mode 3 on a device with more profiles than just one. The blue smack attack is exploiting the L2 cup layer. Some devices react funny when they get hammered down by a big bunch of L2 cup packets that are sent without any delay in between. And this is causing often buffer overflows or just lames the display on the device. It's a denial of service attack. The blue stab attack is about setting a weird name on the device. And actually, this hasn't been discovered by ourselves. This is QNix's work and Colin's pointing out. So Colin is sitting down here. He's also participating in the group. Stand up and say hi. Come on. No. It's all yours. And this name has some characteristics that crash the device, most of Symbian 60 devices, since there's a ASCII to Unicode transformation that isn't handled correctly. So the Unicode is longer than thought because it's replaced by more characters if there's a tab in the ASCII. So it's a buffer overflow as well.
Martin, give us a chance to show it. We haven't showed the previous attacks because we showed it basically last year. I think we should now try to show it. So basically everyone with a Series 60 mobile phone or with a Symbian-based mobile phone maybe want to try to scan for a device.
So everybody having a Symbian 60 phone just hold it up now. So no, nobody has a Series 60 phone. It's mostly Nokia phones with a big display. Yeah, there's 2, 3.
Yeah, true.
Just scan for devices around. This might take a while.
Simply try to scan for devices.
So Marcel sets a name which contains a special character, which is then interpreted differently or just transformed to a Unicode pattern which doesn't match the buffer in the phone. So what you should observe by scanning is that it just blurs out your display and the device reboots. Thrown away phones, Marcel.
No?
No reaction so far? Come on. You all got the latest firmware on your phones? No.
Okay, basically, big problem is that a lot of group, I think a lot of devices are on. I can myself scan for devices. Normally it takes quite some time to gather, what is it, one in the room, 1,000 people or more, to gather such a lot of phones together and really scan for it. But it should generally work, and people nearby, since it's a distance of 10 meters, it should work. No one?
Okay, come on. Let's do the presentation.
At least I know my phone crashes, so. Yeah? So you find it and it's not crashing, so most new phone.
Isn't it a Sony Ericsson you have there? No. Oh. Yours crashed?
Crashed and immediately rebooted. Yeah.
Okay.
This is basically what happens. So if you're in a room where this name is set by one device, they basically can't scan for any other device because every time they find the name, the phone crashes and you can start this over. So what is the chance to get away from this? Any idea? We have to leave the room. or find the person that is acting badly, actually.
All right. Okay, that was the blue step attack. The blue bump is about the bump. Who knows the bump attack? Bump keying. Raise your hand if you know about that. That's a really great attack by Barry from tool.nl. And that's about having a key with very extreme profile in order to slap it into a lock. And in most cases, this lock opens in very short time. And around this time where we heard about this attack, we were about to discover this attack described here. And how it works is that we authenticate, with the authentication abuse, we set ourselves to mode 3, pair up with a device, and tell the partner that we paired with afterwards to delete the key. So in some cases, the device still held the key in the device history, and even though the pairing partner deleted the key, we were able to regenerate a new key that hooked us up an entry on the list again. So this was the blue bump attack. And of course, as a consequence, with a backdoor in this device, you could also still connect to every offered profile again as an authorized user.
Okay, we don't have any of these devices. Any one of you have a Microsoft-based mobile phone PDA with a Bluetooth stack on it? Want to give it a try?
Colin has
Is it working on yours? We take the time to try this. Basically, now I have to scan for some devices. It now takes some time to resolve the names.
I'm very curious what names you have. It's always the fun part. To read phones like, what was it last time? BND, Diensthandy.
Yeah, sometimes it simply times out because the name resolve will not work correctly every time. Yeah, another stall one. Too bad. Maybe the people were inquired and then they switched off when we started scanning or so.
So you crashed all the devices the other
Oh, maybe I crashed all the devices. That's also possible. Maybe I should set my name back. Still missing the request for a female around 30 something that we saw at CeBIT.
What for?
I don't know. Yeah, some more to come, I think.
I remember now.
Colin, what is your name of your phone?
Segfault.
Segfault, okay.
It's not on here yet. Okay.
It's a good job we got 2 hours for this.
Yeah.
Yeah, we almost made
I think
it.
last year there was less phones in this room.
Yeah, well, they trust us now, you see.
Why? I have no idea.
Oh, we have a buggy 6310.
I need some GPS coordinates.
Can you find out your BD address? Is there a menu? Microsoft tell you that much stuff. It's dangerous information. So.
I'm a little bit worried about the Red Hat laptop in this room. Anyhow.
There's somebody who wants to get an email from you.
A whole new idea for a service. Anyhow. Okay, what I now do is I'm looking for the OBEX push profile of this device. There's a man patch for every of these tools, by the way. Okay. Tell them what you really want. Okay. I now know the AFCOM channel of the OBEX push profile, so I can pretend to send a business card by. In this case, I simply connect to it. No, you have one. Okay. There will something come up, and since I told you I sent you a business card, you will obviously accept it. So we now have a connection, as you see, and by the way, I need my root password.
And as you all know, this doesn't need to be authenticated since it's OBEX push, which
and
is
some operating
almost
systems are sorry if you don't know your root password. I have no idea why. And it seems I don't know it either. Okay, here we go.
It's root, isn't it?
What I know is simply we are connected and okay, blah, 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 my device is buggy, I need to authenticate with you, but you can after that you simply can delete the link key. So I say authenticate. Oh. It's taking a little bit more time than I thought it would take. I have to hack a little bit around it. Oh.
Never do live demonstrations.
Yeah, it's really a bad idea.
Next time we have a Flash movie playing.
Yeah, as you see, it says something of pin or key missing, and I have no idea why, actually. It should have it. That's actually weird. Okay, this demonstration is getting really bad. I think we may try it afterwards and simply continue before I waste too much time on it.
Yeah, right.
We will try it. Keep your device on.
So where did we stop? Blue bump. Okay, you now have a slight understanding of what the blue bump is all about. So the next one is the blue snarf ++ attack. As you know, the blue snarf attack was connecting to the OBEX push profile and getting stuff. The blue snarf ++ is it's no longer necessary to guess any file names because there's devices outside there they tell you about. If you just enter ls on an OBEX push session, and they tell you, okay, I have the following browser structure, folder structure that you can delete, write, and do everything you want. So there's just a few devices out there. We didn't discover them too often in the wild. But still, that's a really bad thing to happen if all your contents are away just by riding a train.
Actually, I discovered a device in the hotel room yesterday or the day before yesterday.
I think it was yesterday.
It was yesterday? Maybe. What we need is basically Sony Ericsson K750 something on really, really early Razer from Motorola. Anyone?
Yeah, K750i. Yes.
Okay. Should I scan again or you do give me the address? Basically, I think I have to scan again. Please make it discoverable. Excuse me? Okay. The good thing is now a lot of the names come from the cache, so
Is that the same coward? Now please hack.
I think we spent the complete 2 hours on this gag.
Yeah,
Where it
bend
is?
over
Oh,
in
yeah.
the middle.
I leave it running only for the fun of it. Okay, now this one is timing out, so I simply abort it. The same procedure as before. We have to find the OBEX push channel. That's 5. Address, channel 5. And if it's an older model, we will now see access to it. And since it's called FTP, okay, I think this, okay, you see it here. Oh, this is a fixed one. They say forbidden, which is a good thing. So I need a vulnerable one. Anyone else? There was another one somewhere, okay? What's the name of the phone? Okay. Hello? You fall asleep? I need the phone name. What you just said? Do you see it in the list somewhere? I think I have to scan again. Okay. Only for the fun of it. By the way, don't try to change your name. It will not pop up because it's a cache. Once seen, we have the name forever. The funny thing, even if it takes longer, a lot of people putting on their phone to get a new name on the beamer. It's a foo? Was it the foo or what you said?
Blob.
Not yet. No. Oh, why not? By entering the room, you agreed to get hacked anyhow. Okay, let's give it a try. Since I'm too lazy to decode by myself, I tell them that there's OBEX running on that channel.
All right.
Ooh.
Here we go.
Silence. Please be quiet.
We want to see pictures. All right, very promising. You should have known that the first picture isn't the best one.
Yeah, but
Maybe the safest, though.
the bad thing, they told me I had to implement an MGET, which would be really come in handy.
And it's 2.1 megapixels on this phone.
Yeah, so you see the size is half a mega. No, you don't need that. It's not FTP. It's a Bluetooth FTP. So let me find. Should we show this? Okay. Anyhow.
I have a feeling the next ones in the sequence will get more interesting.
There was this notion in the face, and you really got this new phone instead of getting me a proper present.
Okay, the funny thing is the guy that obviously now the girl doesn't disconnect it or switched off Bluetooth or anything else. So,
Could be outside.
yeah, you're right. Phone memory is also interesting, but I think that's enough for this one. Oh, you know how to do it, basically.
All right, that was over Blue Snarf plus plus. See, and now you know what the plus plus means. The blue spoof, yeah, Marcel made it possible that it's now, you can set an address on your Bluetooth dongle. That doesn't mean that you're fully cloning another device, because the link key is still the part you don't have. So if you wanted to connect to another phone, setting only the address of the headset that is usually connected to the phone is not enough. So the blue spoof just helps for other attacks that we are going to present. So it shows, or it allows you to set any address on your Bluetooth dongle. Mostly it's working best on CSR-based dongles, right?
Basically works on Texas Instruments, Sony, no, Infineon, not Ericsson. Another one that Silicon Wafer or something I've known, best on CSR chips. The CSR chips are the best anyhow, so.
Says who?
I say so.
All right. Yeah, you got to know. No, that's not what I tell them.
No, no, I don't tell this. So basically it's hard to demonstrate, so we skipped it. But in general, sometimes we saw you simply clone the address, connect it, and then all of a sudden the headset doesn't require any authentication, any encryption at all anymore. So you can simply connect it by getting the address of another device, or in this case of the phone. And some phones have some special keys that you enter, and you can read the device, the Bluetooth address from the display. And
Right.
I don't tell you what the address is, find it out by yourself.
Exactly, these devices are disappearing. It's not that easy anymore. But sometimes, if you're lucky, it's just working without any link key to connect, as Marcel says. And this blue spoof attack is very helpful when doing the blue dump attack. Sorry, and I want to point you to the logo we did here. It's a very special one because it's a dump. What the goal of this attack is to dump the link key on a device. There has been an attack by Shake It and Wool published in, I guess it was July or June, something in the middle of this year, where they were showing that it is possible to force two devices to do a pairing in front of an observer, which is most likely an attacker. So sniffing the pairing process puts the attacker into the situation where she can regenerate the link key for this connection and could fully decrypt all the contents communicated there. So that is a very handy thing to do. What these two people proposed in their paper is that they inject a packet in an ongoing connection where they say, okay, I just lost my link key, just spoofed or just formatted as from the other partner of the connection. And what happened there is that the other partner dropped the link key, dumped the link key. So what happened is that as a process happening with Bluetooth devices in general is that a new pairing process is initiated, which then again could be observed by the attacker. Our approach was a little less complicated because it's really hard to inject a packet in an ongoing connection. It's very hard to get the timing right. What our approach was, wait until they are unconnected or disconnected, and then spoof the address of one device, go there and pretend to have lost the link key. In an ideal case, the other device wouldn't drop the link key, but in some cases it would drop the link key, and when the original device comes back, it would ask for another pairing that then could be observed again. On basis of this research, and this is a really brand new attack, we just did some proof of concept today. And this is what we call blue chop attack. And this is one of the first attacks that is not related to device manufacturers anymore. Moreover, this seems to be like a Bluetooth standard thing. And what it does is that it disrupts an established piconet between devices where the addresses are known. So this can have a lot of consequences. You can bother your neighbor in the train using a Bluetooth headset. Once you got all the addresses out, you can disrupt connections to headphones of people listening to MP3, or you could even do stuff that I can't think of at the moment, where Bluetooth connections could probably save lives.
I must say something about it. Are the Bluetooth address supposed to be unique? This is why this attack is working. The address is like the Ethernet address. It's assigned by the IEEE, and it's supposed to be unique, but the vendors implemented a command to change it like they did with Ethernet, and so you have duplicates, and the piconet is no longer unique, and then it simply breaks down.
It's a problem of course, spoofing. It came with spoofing. And it's only possible if the device is capable of multiple connections, because the thing is, you want to break a connection that is already established to this device, so it must be capable of at least handling a second connection. So this means it must be multi-connection capable, and then as another prerequisite, it has to be pageable once it's connected to one device. But this is very likely, since it has the capability of connecting more than just this one, so it should stay pageable.
Pageable means connectable. Sorry for the word confusion.
All right.
Blame the Bluetooth stick.
Yes, not us. So this is like brand new. Can we do a demo? It's quite complicated, since we have two laptops set up, one attacker and one.
I think we should skip this, move this to the end of the talk. Then we can demonstrate it that the piconet really breaks down.
Yes. So, and now we're coming back to old stuff again. That's what Colin and I prepared for last year. And there's newer versions of the Blueprint tool out on the web page. It has more devices in the database. It can now detect how many? 60, 70 different devices. And based on their STP record hashes that we generate with a formula that is written in that paper. You can download it from dropinite.org. BlueTune is an instruction on how to modify a Bluetooth dongle so that you can connect an external antenna that boosts your range quite a bit. There have been quite a few experiments, not only just by our group. The original one was after DEF CON 12, and it was about 1.01 miles that we could reach there. With a usual class 3 device, which has a nominal range of 10 meters, just to explain to you. And then there's some pictures here of consequent experiments. Over here, that is in England, where Adam did some experiments. This is in Salzburg, that's where I'm from. And here's the castle, and from up here we did a snarf about 800 meters distance down on the market square. And this is like preparation work for the car whisperer at night. I just like that picture because it's so, yeah, whatever.
And I like
it is a pretty picture. So what next was Bluver. Actually, I released that last year, 21C3. And within that 1 year, it had about 150,000 downloads. And I wrote there plus X because it got redistributed via different portals as Freeware, Have It Here, Cool Tool, whatever. Even though I never did a second release, I never fixed bugs that were obviously in there as I released it first. Right. But this is also the reason that I did Bluver 2. And that's a successor of this very popular application. And it does a little more. The first version was capable of doing the blue bug attack. Now it can do the hello motor, which is, as you know, similar or related, the blue snarf, and the sending of malformed objects. And since I just finished it today, you can't believe it's really buggy. So it's just the beta phase starting today. It's not the official release. So you all are welcome to test that on your devices. And maybe to some of you owning the, I think, 6230, it's now working on there too. Just got one myself and fixed that. Here are a few screenshots. Here you see the auditing process. It's nothing new. If you had Bluver before installed and used on your phone, it has a new feature which are called quick config, where you can take all the attacks you want to do just before the auditing process. Then it has new logos, of course, because the old ones were infringing the Bluetooth SIG. Here you see the settings. You have settings for, in general, if you want to have that quick config dialog every time. Then you have the Bluebug settings, the settings for Hello Moto, the Blue Snarf, and the MFO configuration. MFO means just malformed objects which you send via OBEX push over to the device. There are some cases where malformed vCards, and I guess Tobias knows that pretty well, can cause trouble on the phone, and also via OBEX, and this is what you can experiment yourself. You can just provide a name and some content to play with. Right. And especially for 22C3, I did the Bluver Breeder. The Breeder enables world domination through peer-to-peer propagation. The Breeder version is able to send out a baby Bluver to other handies. And these babies can then install as a usual midlet, but these babies are too small to breed again, right? So it's just a one-hop distribution that is possible with Breeder, right? Thank you. So the car whisperer, probably you probably remember. Yeah, on the web page, this picture is censored, not here, and I probably uncensored on the web page again because it doesn't make any sense to have it censored. So there's a new version available now. I finished it in summer, it's long ago, I just didn't like to release it. It's just better phone emulation, because what's happening is that the device is connecting as a phone. The laptop is connecting as a phone to a car kit passing by, most likely with an antenna because of the extended range. But then you have to act like a phone. That means you have to tell it all the parameters, you have to send a ring indication, you have to send this in-band ringtone, and this is just a little optimized in version 0.2. Right.
Oh, you removed the statement of don't whisper and drive.
Yeah.
Why?
Yeah, don't whisper and drive. Because there's two setups. There's just this, where you have a stationary antenna here, which boosts, yeah, I just had some worst case values here. It's like if you have a 500-meter range, and this antenna, even though it's homegrown, has a range of at least 800 meters. We just have that here. It's a helix antenna based on a table tennis bed. And you can have like 500 meters, so you would see the car with an average speed of 120 kilometers per hour for about 15 seconds. That's just enough for a fake traffic announcement or something else which you can hear shortly. Wait. What you hear shortly has been a file that Adam provided, kind enough, for fun. It's not available in, wait, I need two hands, just talk it.
No, it's not a big deal. It's just, how often have you've been driving along and another car's passed you and you've wanted to really reach out and communicate with that guy? Maybe tell him how much you admire his driving style or something like that. So I thought, oh, you have this annoying guy that just won't get out the way. Okay, you're behind him, you've tried flashing, you've tried putting your indicators on, you've tried ramming him. He's still there, so I put this together.
Can you hear that?
Oh.
Stop.
Stop. Oh, it's like, we should have tested it. What's that? Our extra name.
I thought you did test it.
No. Okay, I just play them in order. They are maybe not correct.
Maybe we give it to the AV guy that's applied to the whole conference.
I still didn't find the speaker on my laptop.
Okay. Have anyone seen Martin's speaker?
Do you hear that? Yeah. Right. Just go to the next one. Star
Astros.
Yeah.
What I really wanted was actually that most of this is missing, but basically you've got the sirens, you've got a helicopter coming along, you've got a guy saying, put your hands on the dashboard, don't move, pull over to the side.
Yeah, funny enough. So that's what you can do in 15 seconds. Or you can, of course, drive after the car and just inject how long this car stays in your range.
And you can listen as well. When you connect with this, you activate the microphone, so you can actually hear what's going on in the car. So if you want to drive along and listen and maybe join in the conversation.
Because the thing in the implementation is once it receives an in-band ringtone, which can be your message already if you want to, the microphone is open already. So you can hear the in-band ringtone playing in the car and you can hear people reacting to it. And I don't know why that is, because usually you want to start talking once you hit the button to pick up the phone, right? So, but the next slide is where Adam takes over.
Thank you. Okay, so I've been playing with a few old tricks and trying to come up with some new uses for them. And one of them I came up with was the Blue Stalker. And basically what Blue Stalker does is it takes the blue bug attack and uses it to create a circumstance where I can turn your phone into a tracking device. So basically what I do, I have a script, I haven't published it yet, I will do it, it's for BSD, I need to rewrite it for Linux, but I wrote it in an airport waiting lounge when my plane was delayed one day, again. So basically what it does is you tell it the name of a phone or the BD address of a phone that you're interested in, and it will constantly scan for that. When that address comes within range, it will initiate a blue bug attack, connect to the phone, get the phone to send you an SMS message. From the SMS message, you then have the phone number of the phone that you're attacking. You can put that into a GSM tracking service. There's a bunch of these public services. Do you have them over here in Germany? You can put in your mobile phone number and it will tell you where that phone is. Now, normally these guys authenticate by sending you a text message. So you say, my phone number is 123456, and they send a text message to 123456 saying, do you want to be tracked? Is that okay? So I reply on your behalf, because I've connected to your text messaging service. Yeah, that's fine. That's no problem. And then I delete the message. So your phone will go beep, you got a new message, and by the time you've looked at it, my script has read it, replied, and deleted it. So it's gone. So now, as long as your phone's switched on 24 hours a day, I can go to the website and I can find you. So here, as an example, I did tracking myself, and I can see properly. There's a number on there you can't see. There's a little yellow number, which is where it thought I was, and the plus is where I actually was. And that's close enough that I can just drive around with my Bluetooth dongle scanner and find you. So these services are typically accurate so they claim 1 kilometer. I think they dumb them down specifically. Law enforcement and other agencies can probably get more accurate readings on you, but they just give you to the nearest cell, which is about 1 kilometer. But obviously once you're within that range, as we've already demonstrated with the right antenna on your dongle, we can then narrow it right down and find you. So, incidentally, anyone who's interested in playing with those range things, the 1 mile is actually a limitation not of the antenna, but of the protocol. At that point, the propagation delays become such that the protocol breaks down. So you can't, there's no point in playing with bigger and bigger antennas. It's unlikely you'll be able to extend that range beyond a mile, unless, of course, you modify your firmware to do some interesting things. So if anyone's thinking about doing that, we have some plans that we could talk about. So. Okay, so the other cool thing I've been playing with is this. How many of you have seen one of these? Yeah, so Martin had a nice portable device for auditing phones with. So I thought I ought to have one too. And Nokia launched this. And this is really cool because it's, well, A, it's a Nokia and it's not a phone, which is kind of weird. So it's only a PDA. But what they did was they've put an open source implementation on there. So it's running Linux. And unlike a lot of devices where they're using Linux, but they're not actually embracing the whole open source concept, they're just using it as a platform. In this case, Nokia have actually gone out to the open source community and said, okay, here's a platform, develop stuff for it, here's the development environment, here's some resources. They even actually gave them out cheap to open source developers. So if you went along and said, hey, I'm an open source developer, they would give you one for like 1/5 of the normal price, which was really cool. So nice one, Nokia. And because it's running an open source Linux distribution, then we can just pretty much cross-compile anything we want. So I've been porting all of our various tools. I'm not going to actually try and demonstrate it because it would be pretty dull, so I've got some screenshots. And so basically we've got all the standard tools, HCI tool scan. So this is me scanning some phones earlier on. I'm sorry?
Yeah, just remember the address.
Oh, this one, yeah. So I have a script because it's a real pain in the ass to try and do all this. You've only got the touch screen and a pop-up keyboard. So I've written a wrapper script for some of the tools which you can download from the tryfinite.org site, which basically does the, this one does the Bluebug audit. So it'll scan the area and ask if you want to connect to any of these phones. So in this case, I've said yes to connect to the 6310i, and I've got a connected, and I can then actually issue AT commands and dial. And read the phone book. You might want to make a note of that number.
Yeah,
Is that real,
it's been set by Bluver. It's a real number of George W. Bush, since there's a lot of people who want to call him a lot of things.
Give him a ring now.
Yeah, it's in Texas somewhere. You probably won't understand a word.
Yeah, so it's a really cool toy. I recommend you get one. Everything, pretty much everything that we've tried just compiles and runs. So I've got Gnocchi running on it. I've got pretty much all of Marcel's tools. And this next thing we're going to look at, most of what runs on here will be able to run on there, we expect. So we'll have a nice portable auditing device. So Bluenix is our free distribution for auditing Bluetooth devices. It's a Linux live CD. It's running on a 2.6 kernel. It contains the standard BlueZ distribution plus dedicated auditing tools. So this is designed to be a proper auditing tool. It's not a hacker toolkit. You know, it doesn't give you the raw data. What it does is it tests for specific vulnerabilities. So for each vulnerability we identify, we will write a tool that runs on this, and it generates machine-readable output, so you can feed that into databases, you can write front ends for it, and so on. We will be distributing it for free. There'll be an ISO that you can download. Probably there'll be a commercial license. If you're a big company that makes gazillions of dollars from selling this stuff and testing it and trying to make it secure, then we'll probably want you to pay us. But if it's for you guys, because we love you, you can have it for free. So maybe the guys with the video switch can switch to this laptop. Oh, hang on. Wrong desktop. So that's the desktop you get. And basically, you've got a bunch of tools on here that all start blue something, so you can just tab. It's nice and readable. So we can say, is this one of yours by any chance?
Sorry?
Sorry? The Airbus?
Yeah, but it won't make any.
Okay, let's get some more details about one of these. So, where's the Airbus?
Why not the new Airbus?
Well, I'll let Marcel talk more about this because he wrote these tools. So.
There's some funny thing with some devices. I spoke about the SDP record database, and normally the SDP database is public and you see what you get. So this device supports this and this services. The funny thing is it's possible to hide entries in this database. And this basically I think looks really normal. So it does some weird things. What you see, the hex numbers are basically record handles. They start all with hex 10,000 if they read the specification. Some people don't, and then they start with 0. In this case you see actually 5 services, and basically that's it. So we have to find another device. Try one of the, or try even mine, that's more funny. Okay, I let Adam type in the BD address of my Nokia 6310. And the funny thing is, the Nokia device, or many of the Nokia devices have hidden entries, and the funny thing is you normally don't get them. But as you may be seen in this case, the record handles start with hex 10,000, hex 10,001, etc. So basically I came up, okay, let's brute force it. Okay, it's a 32-bit value, so it will take some time to brute force it all. But the good thing is they are playing nice all the time, and they start with hex 10,000, and then they end up with hex 10,100 or something. And so the blue info tool can brute force everything and make assumptions with the already resolved results, and then get you some more information about the device. And if this is not working and you see up some funny things, okay, it looks normal, looks fine, and here we go. Oops. We have some, the funny thing is, it's all identified by a new UID, and basically these are special Nokia-based UIDs. So this one is a PC suite, a very hidden secret for a long, long time by Nokia. So you connect to channel 14 and you get the special PC suite information, and so basically you are Nokia over Bluetooth. I still don't know what these two are, PSM 21505 and PSM 22529. I still assume one of the services capable of upgrading the firmware over Bluetooth. I still haven't reverse engineered. So maybe it's fun to get one of their tools that do it over Bluetooth, over USB cable or serial cable, and try to run it, especially then on a serial cable, and push the data over one of these channels. The last one without a number is Nokia identification, and if you see this SDP record in a phone or whatever, then it's definitely a Nokia device. You see this in headsets, you see this in mobile phones and a lot of other devices, and they also check each other so they can activate special features, etc., and so on. The Sony 7AX don't have any special entries. The 750? Okay, if you find it, give it a try. And there's, oh yeah, so someone found the blue bug attack and found Adam's phone. You can really drive people crazy. I did this once in an airport in Frankfurt, and I had to wait for my plane, and the guy sitting next to me had a Nokia 6310i. And the funny thing is, if you connect and then disconnect, the phone beeps. You can't switch it off. Even if the phone is on vibrate or on silence mode, it always beeps. So I ended up connecting, disconnect, connecting, disconnect, beep, reaches out of his pocket, connecting, disconnect, beep. Oh, it's fun.
But the funny thing is, this beep is so characteristic. You can tell it's a Nokia 6310i. It's very characteristic. Other phones also beep, but different.
It would be fun to find 10 in a place and beep all at the same time, but anyhow. You're checking the... Oh, you're scanning again. I thought we had that joke.
No, we have so much time left.
Oh.
Where's he gone? Bend over. Don't panic.
Press Ctrl C and wait some seconds.
Reset.
Of course, when you have the CD, you also need a Bluetooth dongle, but you can basically buy everyone on the market. So now the important thing. Oh yeah, oh yeah, 750 is funny. It's really nice. As you see, they have a mouse and a keyboard that you can reuse. And they even have, oh, not this one. I saw another one that they say they can support the PAN area network, the personal area network profile, so they can really do TCP/IP directly over L2CAP. The funny thing is, the protocol stack supports it, but there's an application running that supports it. So you can connect and then you get an immediate disconnect. So if you're fast enough and have some fun with it, you can maybe exploit it, but we never tried that. Is it my phone or is it your phone? Then do a blue snuff. Okay. Basically, the machine-readable format is quite easy. It's basically in some kind of HTML, XML syntax, and you get the information there. And even a plain text description what this is now doing. So basically, it waits for, okay, yeah, too many devices around. It basically searches first to find the device if it's really discoverable. Since it's an audit tool, so we won't want to bother those people either hiding it or playing other tricks, so it checks if it's discoverable. Okay, here we go. There's the audit, okay. And finally, we have a verdict, but the verdict in this case is unapplicable, so it's not testable. Let's try it again. Maybe I think there are too many devices around here, and sometimes they have some radio disturbance. Okay. Okay. See, fail, result fail, device is vulnerable. And the other state would pass, and then device is not vulnerable. So pick some other phone. Or the blue bug in this case, because the blue bug is not working on this Nokia. Sometimes they introduce the loopholes later on. In this case, non-vulnerable, result pass. So really easy machinery. Parsable. So maybe switch into the temp directory. The funny thing with these tools is they generate the log files, besides displaying them on the screen, they generate a complete log file with timestamps. And they also generate an HDI dump, which I will talk about later, but basically we capture all the data that we are doing, so we can really see what that tag was and what is going on. Basically, if you don't, there's a command line switch to change the file names, but in general it says uses the address of the target device, the timestamp, what attacker is doing, and then audit for the log file, and snoop for the capture file. The snoop file is written in BT snoop format and can be read by the Linux tool HDI dump or by the frontline sniffer tool from Frontline. Oh, it's there. We will fix this and put the HDI dump also on the CD. Okay, next one. Should we switch back or do you want to show the other tool too? Yeah. Basically, I think you get what this is doing. It's basically the hacker tool. You can, of course, extract all the information that you get from the dump file, but for that, I think you have to write your own application to extract that properly. Maybe it's a challenge for some people. Can we please switch back to the other laptop? Okay, as already mentioned, we have this Snoop file in the BT Snoop format, and there have been since the beginning of Bluetooth around hardware sniffers and other devices where you can sniff traffic over the air. Bluetooth with its piconet and scatternet structure is not like wireless LAN, where you activate a wireless LAN device and it sends out data to the air and makes it itself visible, discoverable and vulnerable against other devices. So basically in Bluetooth, if there's no connection, there is no data ongoing, so there's no radio transmission at all. And even if there's radio transmission, this device changes the channel, one of the 79 channels, 1,600 times a second, so you have to follow this hopping sequence to really extract any data, and to be honest, it's not really easy to do this. Anyhow, there are some sniffers out there that can do this, but basically they are designed so they can work in labs, and if you have a special test set up, so they really work. If you want to go out and sniff a connection, what two devices are doing, you maybe have to do a lot of preparation. In most cases, you also need the PIN or the link key from these people, and so it might not work in all cases what you want to try to do with it. So in general, sniffing like Wi-Fi is not as easy. But we have some devices around. Basically, the first one is a Tectonics. It is originally made by DigiAnswer. It's one of the first ones that were out there. Now it's bought by Frontline. It's called BPA 105. The previous one was called BPA 100. We have from Ketsi, or Ketsi got bought by LaCroix, the Merlin 2 and the Tracer Trainer. This one was quite expensive at that time, and it's still, you can still buy it, but it's, I think that's selling for something around 20,000 euros or something around. The Ketsi is, I have now I think 12,000 euros or something, or 15 or something around. The Tracer Trainer ends up something to be 40,000 euro and so on. But the good thing with this one is this general case, and you can place this with Wi-Fi modules and Zigbee modules or whatever Wi-Fi you want to do. The smallest one is the Frontline sniffer from Frontline Test Equipment. It's basically a CSR-based standard dongle with a special hardware, with a special firmware designed for doing the sniffing. Since the dongle has all the radio components on it, they made a special firmware to put on this dongle and then use it for sniffing. There's three different types of sniffing. So local sniffing is meaning by HCI dump. So everything that the stack, the Bluetooth stack is doing, sending down to the chip is can you read with the HCI dump, and you actually already saw that on the screens when we did the previous attack. So for example, if you read out the name, etc., then you see the HCI commands flying down, and if you have upper layers, L2CAP, RFCOM, OBEX, etc., it will simply decode that to accept you don't tell them to do this if you want to have binary data, which you can also do. I think it's, but by the way, who wants to look at this crap? Another thing is piconet sniffing. Basically, if you develop, you have already one device under your control, and so you have one part of the piconet, and you want to see what's going on in the lower layers. For example, L2CAP, not L2CAP, LMP, and maybe on the baseband. Then you need some kind of piconet sniffing. Unfortunately, the Tectonics was capable of doing this, or the DigiAnswer. The newer ones are no longer capable of doing this. They're only air sniffers, the third category. So basically you have the two devices, and you need a third device with a Windows laptop, of course, where you can do the sniffing with, and etc. Okay, you want to do the last parts? Okay, basically we have some time to do some more tests. I think it's really needed. The conclusion behind this is the same basically as last year. Bluetooth is in general a secure standard. They really designed it well, especially on lower layers. There's some things with the Blue Chop attack, etc. Okay, that's a little problem they haven't thought of, but maybe they're going to fix it. The big problems are application layers. So the manufacturers reused components, the OBEX stack from infrared protocol. Okay, infrared you needed site, Bluetooth you don't need sites. You can walk by and steal the phone book, etc. And we're trying to get the manufacturers in the way that they think about security, and that they think about reusing components and reusing components in a sane way, so they really know what they are doing. For this, we got hired by the Bluetooth SIG, and at the Unplug Fest. The Unplug Fest is an event that is organized by the Bluetooth SIG 3 times a year, one in America or Canada, one in Europe, and one in Asia. And every company that comes to the Unplugged Fest have to sign an NDA so that they can't talk about any results on this. And after that, they can test each other prototypes and sometimes final products on a really NDA-based event, so they can't get any advantage of what knowledge they get from the test from the other company. It's really a good thing, and the good thing is the Bluetooth SIG invited us to do the security testing. So basically what people dream of, we sit there and wait for other people to come to us and, okay, please crack my device. And most times we did actually.
Allegedly. But then they fix them, so that's cool. That's the whole point. The prototype comes, it's broken, we prove it's broken, they fix it. So what actually hits the street is a secure device. So it's, yeah, it's good.
One thing that's really bad at the communication channels, if you want to try to communicate with the Bluetooth SIG, we try to really improve it so that other people that found something can approach them and tell them, okay, here's a problem, and then they try to investigate it. I think the best time at the moment is if you find something, drop us an email and we will try to look into it. Some things we try to get into the specification is, for example, to get the interfaces clearer. So that you really knows what the device is doing. For example, incoming connection. This means nothing. Oh, do you want to accept our business card from this device, etc.? Or this device wants to connect to your internet line. Do you want to allow this, etc.? So the user interface must be clear. Obviously, the most mobile manufacturers are not really taking any advices on how to design their UI. It's getting better, but I think it's still a problem. And I mentioned the weird names that Bluetooth specification has for tasks that or for states that are known totally different in the normal world. Manage the security at application level. Okay, every application should provide its own security, so they should really know what they are doing. And the thing using a policy manager is, okay, we really need to have separate security models for every profile that is running on a device. And modern phones, I think, have up to 15 different profiles. You can stream audio, MP3s with them. You can use it as mouse replacement or keyboard replacement or whatever. Okay, Tri-Finite Group, Martin already mentioned that. It's not only 3 of us, it's besides Colin also Tim Herman, Mark Rowe from Pentest, and a nice little whatever toy it is.
It's an iBo.
Yeah. Okay, mentioned already, much more information, trifinite.org. The thing is, the CD called is Bluenix. The core behind it is Trust, Trifinite Unified Security Testing, because it's a general framework to do the security audits. And if I show you the source code of the audit tools, most of them are only 10 lines because the framework behind it is really doing the complete job in the background. And it's quite easy to write audit tools, but it's only for audit, it's not for hacking. Contact at trifinite.org, or our email addresses are, Google for them, you will find them. Okay, next challenge.
You all know what that is, right?
Who knows it? Hands up.
We have to apologize, it's a little late because that would have been the perfect Christmas present for the geek girl.
By the way, who used it?
It's a vibrator. If you want, I can read you the specifications. And this vibrator reacts on Bluetooth. It's connecting to a phone, and I can read it to you. It's cutting-edge electronics. It's wireless Bluetooth technology. 2 years in design and development. It's an intelligent CPU, a turbo boost circuitry for more motor power, lithium-ion battery technology, power status and charge indicator, wherever this is that you can see it. 90 millimeters length by 33 millimeters in diameter, 14.5 centimeters high tensile coated cable antenna or extractor.
By the way, we don't get any money for advertising this.
No. So you have to find the URL yourself. So, but the things it can do, and that's really where it's investigating on when you try to hack this, it has 45 possible effects from any one letter, and in total there is 7,200 variations from a single text message. So can you imagine all the girls freaking out just when they sense your proximity?
They claim it's not visible or not discoverable by default. We will see.
Questions?
Since we have plenty of time, if you want to see some of the other attacks that we talked about, the blue bug or the snarf or anything like that, then just ask. But otherwise, any questions?
Hello? I want to add, there is in Germany a service to track your mobile down, at least if you are a customer of O2 Online. And O2, they have a service for all O2 customers. And you can to their webpage, and they must enter a password, which is fortunately usually the birthday date, except if you're Asian, then it is 1111.
Nice. So you mean they're not actually sending any kind of authentication to the device? You just put the phone number in and the password?
You go to O2 Online, and you can log in with this customer PIN code and then track your own phone down.
Yeah, crazy. Saves me a lot of trouble. So thank you.
That's the same with the T-Mobile access point. They know about it. It was publicly published that the T-Mobile access point uses a similar scheme. So if you find a T-Mobile phone, you can have internet access on any train station, airport, or whatever for free, because they still haven't fixed this.
Any other questions? No? Okay, then thank you.
Okay,
Question over there. Sorry.
Please use the microphone over there.
Here?
I'll use this one.
Yeah, come to the front, please.
Hello. Do you have a few tips for car models to watch for on the drive home today?
For car models.
Which have default installs of vulnerable speaking equipment?
One was obvious.
Which are car whisperer capable.
Which are, of course, which have the special
Compatible,
features.
okay.
Compatible, yeah.
So I think it
Certified.
went through the press quite a lot that a big German manufacturer has an issue. Yeah, their logo, they modified ours. and yeah, and we're gonna sue them.
Are they discoverable usually by default?
They are, but I just got very good information because they really improved. They, I think the next generation turns off after 5 seconds that your car moves, or it turns off if you're faster than a certain velocity. So you just can pair a new device once the car parks and is in the parking lot and it's not moving, whatever. So they worked around pretty well.
I can't pair if it's parking, or I can?
You can, but once it's driving and the car is moving, that's exactly when an attacker most likely tries to catch you, then you can't connect anymore.
I can't do it on the road. Okay, so no fun on the drive home.
Not with this older models, maybe. And there's a lot of aftermarket car kits where people build them in themselves. So there's a pretty bunch of them being vulnerable. You just try that out.
So the advice to everyone is just let HCI tool running on the drive home and have fun.
There's another good advice I might point out. If you have a Bluetooth phone, and Bluetooth is discoverable for whatever reason, you want to be seen, you want to be contacted by someone else, don't leave it in your car, because certain thieves try to scan for Bluetooth devices in cars, and they find a device in range, and then they pick this car to open it and get stuff about it, because they know there's a phone or something, maybe also a laptop or whatever in there. So basically, if you leave something in your car, don't leave your Bluetooth on.
Yeah, thieves discover it. But there's a funny story, I told that at What the Heck already. There's fortune tellers using Bluetooth technology in order to find out the names of the audience gathered around, so they would know that there's a person with a very strange name or whatever, and of course they pick these persons, and if they have a vulnerable phone, they know the last person called was mama, and before it was his wife or whatever. So the fortune teller could make out a very realistic story out of these facts.
I have one question. Is there any database where I can put in the name of a device, brand or something, and find out what attacks are known to work on it, so I can choose a proper device before buying it?
Basically, Adam started to have a small database, but I think it's out of date. The problem with this is we like to do this, but obviously we can't go out and buy every phone. It would cost us a fortune. They produce them like somebody else will change their underwear. But I think we may get up and have a database up running at some point. The big thing is they changed the firmware, so we also have to track the firmware, etc., so you can really see what you're buying. We stopped putting the models on our talk slides. The previous talk, they find some from the previous, okay, this model is vulnerable, this model is vulnerable, etc. But we need really help to really get this anything in the right direction. And basically the Bluenix CD with the audit tools on it is one way to really, okay, say this device is vulnerable, this device is not vulnerable to this attack, and then you can send in the firmware version and then we can have a database. But the CD is I think it will be published in January or February next year. So we need an audit tool to really say it's vulnerable or not vulnerable.
Okay, I think that's it. So thank you for listening, and maybe see you next year.